we will solve this system of non-homogeneous equation. First we find a homogeneous solution, and then we find the non-homogeneous part, which is the particular solution. So first, the homogeneous solution. For this, we find the eigenvalues and then eigenvectors. So eigenvalues. Which we solve this equation. The characteristic equation. Right. So we have determinant of, I just copy that matrix. And we subtract lambda on the diagonal. Determinant of that should be equal to 0. Right. So this should be easy. I will just, based on any row or any column, I will use the last row or the last column. It doesn't really matter. If we use this row, we're going to have 0 times the 2 by 2 matrix, which doesn't matter, which go to 0, and then minus 0, a 2 by 2 matrix, which will go to 0, and then we have plus 3 minus lambda. If we cover the row and the column that containing 3 minus lambda, we're left with this matrix. So we're going to have 0 minus lambda, so that's minus lambda, and then minus lambda, minus 3, minus 3, equal to 0. This is going to be a long problem, so I try to save space here. So 3 minus lambdas, 2 by 2 determinant give us lambda square minus, sorry, I forgot the negative 3 here. Lambda square minus 9 equal to 0. Lambda square minus 9 is lambda minus 3, lambda plus 3. 3 minus lambda and lambda minus 3, we can factor out the negative, and we have lambda minus 3 square, lambda plus 3. So we have lambda equal to 3, multiplicity of 2, and lambda equal to negative 3. Right. So that is the eigenvalues. Now we'll find the eigenvectors. Corresponding to lambda equal to 3, and there are 2 of them. Right. So for eigenvectors, we will solve the matrix equation A minus lambda I times the vector V equal to a 0 vector. So first we have the matrix, the original matrix, 0, negative 3, 0, negative 3, 0, 0, 0, 0, and 3. We will subtract the diagonal entries by lambda, so we minus 3 on the diagonal. And do that, we should have the matrix. By the way, we still multiply with V, and that equal to a 0 vector. Right. So that matrix form, that should be -3, -3, 0, -3, -3, and 0, and all zeros. V1, V2, V3, separate some space, and that equal to 0 vector. I will do reduce row echelon form here. Second matrix, that alpha zoom 3 row 4 columns, so that's good. -3, -3, negative, and -3, 0 everywhere else, so that's good. So we have that 1, 1, 0, 0, 0, 0 everywhere else. Note that in terms of the pivot entry, we only have one, that is on the first column of V1. So V1 is not free. V2 and V3 does not have, V2 and V3 do not have the pivot entry, so V2 and V3 will be free. As you see, there's no leading non-zero entry. Right, so we only have the first row, V1 plus V2 equal to 0, and V2 and V3 are free. Or arbitrary. So if we write V1 equal to negative V2, or in the vector form, V1 is negative V2, and V2 is V2. I don't know how I write that. V2 is free, so equal to itself. V3 is free, equal to itself. If we write that, we can have in the term of V2 and V3, we can write like that. And factor out of V2, -1, 1, 0, and then V3, 0, 0, 1. So we have two eigenvectors corresponding to this eigenvalues. V1 we can say -1, 1, 0, and V2 0, 0, and 1. That's corresponding to this repeated eigenvalues. Now we do the same thing kind of for lambda equal to -3. This is going to be a long problem. That's lambda 3. Right. So we have the matrix 0, -3, 0, -3, 0, 0, 0, 0, 3, and then subtract the lambda. In this case, subtract -3, which is +3. and so the matrix would be -3, -3, 0, -3, 3, 0, 0, 0, 6, multiplied by V1, V2, V3. And let's do reduced row echelon form for that. Right. Reduced row echelon form, 3 rows, 4 columns. 3, -3, -3, 3, and 0, and 6. We have 1, -1, 0, 0, 0, 1, 0, 0, 0, V1, V2, V3, we see that there's a 1 here and there's a 1 here. So we know that, actually let's just write down, we see what happened. Right. Usually like that we see V2 is 3, but actually it is not. Right. Let's see the first equation. Right. What we have, the first equation is V1 minus V2. Actually V2 is 3. Is equal to 0. And then the second one, V3, is equal to 0. Right. Now again, we have the 1 on the first column. So V1 is not 3. V3 is not 3. There's no 0 here. So that one is 3. So V2 is 3. So if we're going to write the vector V1, V2, V3, V1 is equal to V2, V2 is 3, so equal to itself, V3 is equal to 0. Factor out of V2, we have 1, 1, and 0. So the eigenvectors number 3 is equal to 1, 1, and 0. That's corresponding to this eigenvectors. Now put them together. We have the homogeneous solution. I know it's going to be a long problem, but I just want to put the homogeneous solution on this first page. So x equal to C1 E lambda 1 T V1 C2 E lambda 2 T V2 C3 V C3 E lambda 3 T V3 C1 E to the lambda 1 is 3 T, and the first vector was 1, 1, 0. Let's just a little bit. Yep. Negative 1, 1, negative 1, 1, 0, plus C2 E to the 3T, V2 is 0, 0, 1, and plus C3 e to the negative 3t. The vector is 1, 1, and 0. Let's zoom out for a moment. Right, so we find the eigenvalues and then the eigenvectors and put all of that together in the term of the solution. Right, so that is the homogeneous solution. Next, we will find the particular solution. Right. For particular solution, now we have to go back from the beginning and see less. So we have 3e to the 5t. If we compare to the solution now we have e to the negative 3t and e to the 3t, which is different than this. So if we have to guess, the form will be a to the e5t. Right. And for sine 2t, we can say a cosine 2t, b cosine 2t. Let's use this. And then the last one, it is polynomial. It's different than, again, it must be different than e to negative 3t and e to the 3t, our solution, our homogeneous solution. So in that case, we say, let's see, dt plus e. Usually we don't want to use d, but that's fine. So all of this together is going to be our guess. A particular solution, we'll take that form. So first we're going to write the particular solution will be in this form. We have a, but instead of write like that, we will write e to the 5t, a vector a, plus cosine of 2b, 2t, vector b, plus sine of 2t, vector c, plus t times vector d, and vector e. Right. You can see it is exactly like the one we have in term of in green ink, except we use the matrix form, so we use the boldface lowercase letter instead. So that is the particular solution. It is the vector form, so let's just put that as the vector form. Right. Or we can just say y or x, it doesn't really matter. It's just x then. That particular solution. And then we'll take the derivative of this. Just take the derivative. The constant will stay at the end and doesn't do anything. E to the 5c is 5, e to the 5t. Constant will stay. Negative 2 sine of 2a, 2t times the vector b plus 2 cosine of t times vector c, and plus 1 times vector d, and derivative of a constant 1 here is going to be 0, so we don't have anything there. Right. And then if we substitute this 2, if we substitute that into our equation, we should have the following, which will be extremely long. The left hand side is the derivative, so we say 5 e to the 5t a minus 2 sine 2t b plus 2 cosine of t, cosine of 2t c plus d. So that is the left hand side is the derivative. The right hand side is much longer than this, so I'm not going to put in the same row. So that is the left hand side. The right hand side, first we have a times x, so we're going to write e to the 5a 5t big A little a. So we just multiply the matrix A into x, so that's what we have. Plus cosine of 2t a b plus sine of 2t a c t a d and a e, and then plus the input function f. I'm going to put that in the matrix form in term like this. I could put 3, 0, and 0, e to the 5t plus 0, 1, 0 for the sine 2t, and 0, 0, and 9 t. Note that what we have here is corresponding to the input function of 3e to the 5t sine of 2t and 9t. We just separate the term like this. Right. Next is just the undetermined coefficient. Now let's look at e to the 5t. What do we have? If we put them together, I use this in red ink. Then we look at this term. In particular, e to the 5t and this. We can write five e to the 5t a equal to e to the 5t a little a plus 300 e to the 5t. Now if we match the same term on both either side. Now if we ignore the e to the 5t, and we will have a 5a on the left hand side, and then we move that term to the left hand side as well, so we have minus aa will be equal to 300. Right. Now we cannot really do this. We can factor out a, but if we factor out a, first of all, let's move this over because we need a lot of space. We cannot just factor out a, but we can, if we do this, it doesn't make any sense. We cannot just take 5 minus a like that. This will be wrong. What we need to do is have to put the identity matrix there. Now we have the matrix minus the matrix, so that will work. So we'll do the reduced row echelon form, and we should be able to find the matrix A, or the vector A. So 5i minus A identity matrix is 5 times identity matrix, will have 5, 5, 5, 5 minus 8. So 5a will be 5, 5, and 5. So that is the identity matrix times 5. And then we minus a. A is, remember, is minus 3 here, minus 3, and minus 3. So if we put the matrix and then do the reduced row echelon form, do that quickly. 5, negative 3, negative 3, 5, 0, 0, 2, 0, 0, and then A. Just do this for the first prompt. Reduce row echelon form, apply to the matrix 3 by 4, which is good. 5, negative 3, 3, negative 3, 5, 0, 2, and 0. Convert that to fraction. So we have A equal to 15 over 16, negative 9 over 16, and 0. So that is A. Right. That's A. Now we will match the sine 2t and cosine 3t. Cosine 2t. That's a little bit of work. Right. Next, we have sine 2t here, and the sine 2t here, and the sine 2t there. So negative 2. Now we just ignore the sine 2t. And we write like that. Plus 0, 1, 0. Kind of have to write a lot smaller now. And then we look at cosine of 2t. And that's what we have. To C equal to AB. Right. So when we do that, the bottom equation we have that we use substitution. This system equation. The reason I put this together because those sine cosine usually goes together. And then if we solve for this one, we will have we can solve for C. So C will be equal to 1/2 AB. And we substitute that into this. And then move on the one side, move everything on one side. We should have minus 2B minus 1/2 AB equal to 0, 1, 0. Zero, 1, 0. Right. Again, if we factor out B, we have to put the identity matrix there. So that will give us a -2 times identity matrix minus 1/2 matrix A, B equal to 0, 1, 0. To save time, I'll just go ahead and say the matrix B. If we do it, we're going to get 0, -12 over, -2 over 13. Zero. After we do the reduced row echelon form, we should get that. And finally, actually no, there's a few more. And then C equal to 1/2 AB. We should have, we just take 1/2 of A times the matrix B we just found, and we should have 3 over 13, 0 and 0. That for B. And then next, let's match the constant. Now we have D on this side, and that's a constant. On the right hand side, we have AE. That's the constant. So we have D equal to AE. We don't know what that is yet. But we also know that on this side we have the 0t, and on the right hand side we do not have any. Zero vector. So in that case, sorry. Yeah, there's a t there as well. And the 0 there doesn't really matter. So we have AD plus that matrix equal to 0. Plus that make the vector of 0, 0, 9. Of course, we're going to drop the t in that equation and equal to 0. And from that, we can solve for D. Is equal to, let's just write AD (0, 0, -9), and reduced row echelon form. We should have the vector D of 0, 0, -1. And now if we substitute that back, into that, we can solve for E. So AE equal to D, reduced row echelon form, we have E equal to, if we put that in the calculator, we should have 0, 0, -3. Sorry, I copied them backward. The D should be 0, 0, -3. So this would be -3. And the E is 0, 0. Sorry, I got them backward. Right, of course, we solve for AD equal to 0, 0, -9. We should have 0, 0, -3. And then substitute back in that, we have E is 0, 0, -1. Right. and then put all together, we have the particular solution. Right. So first will be e to the 5t times the matrix vector A. What is A? Right, 15, 16, that is A. Negative 9 over 16 and 0. And then B, 0, negative 2. B will multiply by cosine 2t. 0, negative 2 over 13, 0. Sine 2t, 3 over 13, 0, 0. That is C. And then T, matrix D is 0, 0, negative 3. And the matrix E is 1 times 0, 0, negative 1. And put all of that together, we will have 15 over 16 e to the 5t plus 3 over 13 sine 2t. The middle one, we have e to the 5t, negative 9 over 16 e to the 5t, negative 2 over 13 cosine 2t, and then no sine t and nothing else. The bottom line is negative 3t minus 1. So that is the particular solution. And then for the general solution, equal to homogeneous solution plus particular solution. Homogeneous solution is from the previous page. This is the homogeneous solution. Right. Put them together, we should have the solution. I will zoom out. That doesn't fit here. Right. Again, this is just a long problem. The part where we find the homogeneous solution, that is just the eigenvalues and the eigenvectors. Our particular solution is kind of like the undetermined coefficient we did before, except this time it is in the vector form, which turned out to be a little bit complicated. When we solve for all the vectors and put them together, we should have the particular solution.